Greetings everyone, my name is Arena and I am doing a video presentation for my EDIT 6150 class on Web 2.0 technology. I decided to focus on citizen science in the classroom and I'll be looking at online citizen science projects for elementary school. Because I'm training to be an elementary school teacher and that is what was of interest to me. If you're a teacher, I can bet you have had to answer the question, why do we have to learn this stuff? This is because students are becoming increasingly aware that what they do in school should matter in the real world. And it is frustrating. It is a frustrating question for many teachers, and citizen science tries to bring real world applications to what students learn in class. So, what is citizen science? It's a research practice where members of the public, not necessarily scientists, collaborate with professional scientists to conduct scientific research by collecting or analyzing data for real-world scientific research studies. So there are various levels that someone can get involved, like you can make observations and record your observation. You can do investigations where you will need training. You can analyze and interpret data that's already been placed, that's already been collected. You can ask questions or you can collect the data yourself and put it in the Citizen Science Project website. So because it's a Web uh, 2.0 project, I will look at citizen science projects that are usually online. They're usually referred to as cyber science projects, citizen cyber science projects. And I'll focus mainly on 4 elementary school projects, which you can implement from pre-K to 5th grade. And one that, because I'm in Athens, Georgia, one that's particularly interesting in Georgia. So let's start with Journey North. So Journey North is a global study of wildlife migration and seasonal change. So one of the Journey North projects is the Tulip Garden Project, where students plant a specific type of tulip bulb in the fall, then make observations and report when the first plants and flowers appear. Then your data is aggregated onto a map with the data from other participating classrooms, which gives you a great visual to track the arrival of spring as measured by blooming tulips. You can extend your lesson by learning about how plants grow from the time they germinate up to the time they flower and how long it takes, soil types, does soil influence how things grow and where they grow. You can also track the monarch butterfly. This is where students report sightings of monarch butterflies and their data is plotted on a global map. As students track the migration of the monarchs, they learn about animal behavior and adaptations as well as the life cycle of the monarch butterfly, which, like the life cycle of a monarch butterfly, that's of a butterfly, practically kindergarten students also do that. They can learn about butterflies and their life cycle. And you can also incorporate geography. You look at data from different parts of the world. And then we have the project Feeder Watch, which is very simple and it has different ways of collecting data. But for elementary school students, they can actually, for creativity, they can actually create a bird feeder themselves or design one. And what they will need to do is to submit information to the lab of the birds they have sighted. And then the other one is the bee hunt, which invites students to collect data in one of 4 ways. So they can either do inventory pollinators at a selected site using digital photographs, compare species in 2 patches, provide nesting sites for mason bees and observe their activities, or use balls and soapy water to collect insects for a more thorough inventory of species. For elementary classroom, a digital photo inventory would likely be the easiest, and they can learn about plants, about pollination, about parts of an insect, among other things. And then for Athens, we have the Frogwatch USA. So this is a project that focuses uh, on how uh, the environment is affected by the frog population. So individuals are actually trained on how to listen to frog calls, and they're supposed to do this 3 times in a year. You do it for 3 minutes, so it doesn't actually take a lot of your time. Then you can come to the site. When you go to the site, it's Frogwatch USA. We have very many chapters. Here we have one at Sandy Creek Frog Watchers. You can register to be a partner and collect information in Athens. So actually the community can get involved. You come to the site, you can collect your data. This is where you put it. You just sign in and put in the data. You need to be a member for this one. And then you can see the data and plot graphs and do math by analyzing the data that's already been collected. So we have parents, we have teachers who've already done this project in their class, and I want to show you a video of the same, of these teachers. There we go.
The STEM project is focused on engaging third grade students in real science research and empowering how students are happening. Our team and appreciating is partnering with schools and Sandusky City Schools, among other partners, to reimagine science education in the Sandusky area. A key component of this National Science Foundation grant project is citizen science research, real-world research that even kids with the right training can conduct using the same methods and instruments used by real scientists. Third grade teachers and their students have been carrying out the citizen science research project guided by Mitch Mankic and his team from the Toledo Zoo. They've learned how to monitor monarch butterflies, bees, and other pollinators. Pollinator gardens planted on school grounds are now home to many native Ohio plant species, including milkweed and important food source products. Data collected by students looking at gardens is combined with that of many other sites across the country. Important information to help us learn how to preserve and protect endangered pollinators. Fourth grade teachers and their students have been involved in other citizen science research projects. One of these is Frogwatch USA, led by Dr. Eileen Underwood of Bowling Green State University Herpetology Lab. Some Idaho fourth graders have been learning about prairie frog populations and the roles they play in Sandusky's ecosystems. Other fourth grade scientists are literally engaged in groundbreaking work as they measure water infiltration in their school's pollinator rain garden. Celine Heminger and her team in the Erie Soil and Water Conservation District are teaching students how their soil monitoring can help influence responsible local land use and improve local water quality. To measure that water quality, some fifth grade Idaho teachers and students are studying the Sandusky Bay with the help of Dr. Matt Hardy of Bowling Green State University Marine Lab. Other fifth grade researchers are studying area creeks through a partnership with Ohio State University Stone Lab and Drs. Chris Winslow and Kristen Fussell. Data collected from field site visits is evidently cold database where students can see how their findings contribute to what has been documented around the world. Perhaps what these students discover will help to solve the problem of harmful effluents that threaten local water supplies. Middle school teachers and their students will begin their own research in the fall of 2016, engaging in similar projects, but delving deeper into various aspects of the data collected. It is our hope that all students in the Idaho STEM project will see that they can make real contributions to their communities and even the world through involvement in citizen science research.
So, as you can see, this is a very practical way. It's a very practical way of incorporating science, technology into what students are learning in class, making it really relevant. And how does it relate to the forces? One of the very, very fundamental things is it involves collaboration and communication, because once you make observations, you have to collect the data and communicate accurate data into the system. You have to input the accurate data into the system, which is a collaboration, and students learn that once they and students learn that science is not learned in isolation. You have to cooperate with other individuals. And then there's the aspect of critical thinking, because students need to make observations from their experiences, reflect on those experiences, apply reason and conceptualization, and then synthesize the information into a meaningful belief. And then there's the aspect of creativity, which sometimes it's not so obvious, especially in elementary school, except for maybe creating artwork where they can, in the bird feeder watch, they can actually create bird feeders, or they can suggest improvements on how to collect the data. And for other citizens, it's actually led to scientific discovery where scientists maybe did not have enough data, or they did not notice something. What are the limitations and recommendations? The limitations are sometimes it is very skewed, because there are some participants which are very engaging and they're always collecting data. So you have data from one place and you don't have all the data from different places. And then volunteers participate in the project, the more they learn. So they need more participation. You need to put in more effort, not just collecting data. You need to incorporate a whole system, which is very essential, especially in elementary school, where you can do lessons related to what you're doing. And then we would recommend gamification so that you can incorporate millennials. You can do apps where where they will be able to gamify this data collection so that we can encourage more participation. Thank you so much for listening, and I will see you later. Bye bye.